All right, this is AP Chemistry topic 3.8, representations of solutions. And I'm actually just going to show you a couple of things that I designed and put in my notes because I think it does a pretty good job. So when we're representing solutions, the two things that we really want to think about are the proportions of the components relative to each other. So that's thinking about concentrations and also balancing charge. And then also the orientation around charges. Okay, so if you have like an ion dipole situation. So let's look at each one of these. So we're going to start with a diagram that illustrates a 0.2 molar solution of NaCl, and then they want us to sketch the same volume of something of 0.4. So this is 0.2, and then we're going to sketch 0.4. So the question becomes, what is that going to look like? So this concentration is double, and so that means we're going to have twice as many particles in the same amount of volume. So it's going to look like this. Now note that I have twice as many of each kind of particle as I did before, but I have the same number of NAs as I do CLs, and that's because we have one NA for every one CL. Now, if we had something that had different proportions based on their charges, then you would need to make sure that you keep your proportions the same. So like if we had something like BaCl2, then we need to make sure that we had 2 CAs for every one BA. Now on this side, we're going to look at how things might arrange themselves in solutions. And we see this pretty commonly on the AP exam. So in this case, we're going to take that same sodium chloride solution and we're going to put water around it. And so I want to show you both situations. So how water would orient itself around sodium, which is Na+, and how it would orient around chloride, which is Cl-. So notice what I've done here is I've oriented the dipole so that the partial negative is facing the positive, and in this case the partial positive is facing the negative. Now a couple of things that you want to make sure to do here. First of all, if they ask you to draw water in this way, please draw water in this way. So by drawing water this way, it allows us to clearly see where the partial positive and the partial negative are. If you were to draw these in a straight line, first of all, that is not accurate geometry, but second of all, it makes it very hard for the readers to understand which part of the molecule you intended to be positive and which part of the molecule you intended to be negative. Second of all, if it asks you to draw a certain number of waters, and in this prompt I didn't say that, but if it says to draw 4 waters, please draw 4 waters. So make sure that you read the question and answer the question as it is asked. And that's pretty much it. So make sure that you're thinking about proportions based on charges and also based on the concentrations that it's giving you, and think about orientation relative to dipoles or charges, and that's how we represent solutions.